All right, welcome to today's lecture. For the first and second part of today, we're going to focus on some design issues when it comes to object-oriented programming. And possibly next week, we'll also be looking at some other topics that relate to object-oriented design. So we're going to start gently today by looking at overall what design usually entails. But before we get into that, I'm going to give you a little bit of background to how software development actually occurs, and then we're going to talk more about the specifics of object-oriented design processes. Yes? All right, so we're going to focus on software development activities. We're going to look at how to determine different components that are used in your actual object-oriented design and whatever relationships between them. And then in the second part, we're going to look at specific tools that can be used to specify your design. All right? So let's talk about software development activities in general. Now, when you're about to create a software, there are four basic things that you really need to do. One, you have to decide, okay, what are going to be the things that must be included in this software, right? What should it be able to do? And that we tend to call the requirements for the software. Then you have to now create a way how these things are going to be accomplished. And that generally is what we call the design. Then you have to actually do the implementation of what you are required to do and how you say you're going to do. And that's what we tend to focus on to a large extent as building the software. And so that's the implementation of your code. And then once you have implemented it, then you want to be able to test, to verify, and validate. Okay? Now, sometimes you do a little of each, and then you go back to the previous activity, and then you move back and forth and so on, because in a lot of cases, you don't have perfect information. And when you get to more in-depth software development courses, you will learn some of the issues associated with building software, why these things can never be really linear. So, in general, establishing the requirement is about analyzing the problem and setting up what is to be done. And then you have to now specify a solution, right? And that solution is basically a description of how you're going to accomplish what is to be accomplished based on what you set in your requirements. And then you choose a programming language and implement your code. And of course, thereafter you test. Now, as I said earlier, your requirement is usually what is to be done, not how it is done. Okay? So it's just what is to be done. Don't expect to establish your requirements and never have them change once you have discussed them. Right? These things have to be refined over time. Careful attention has to be paid to them. And as you probably reach further in the other areas or other aspects of your project, you may have to go back and modify some of what you would have specified there. Now, once you are satisfied generally with at least some aspects of what is required for your program, then you start out by determining how you're going to accomplish what is required. Now, there are two main design strategies. One is what we call functional design, where the solution that you're about to create is broken down into units that have certain functions. Like I said, this unit is going to be responsible for doing these things. This unit will be required to do these other things, and this unit will be required to do these other things. Yes? Then the alternative, another approach, or the alternative approach, is what we call the object-oriented design, where you start out now by specifying classes and how they will interact with each other. Because now you have to use the information in your requirements, maybe some of the wording and the descriptions in your requirements to start to elicit or extract what are the things that need to be represented as what we have discussed in the past week as classes. Okay? And then, you know, each class has attributes and behaviors, and we'll talk more about that in a little while. Now, once you have come up with your design, then it's time to put it in writing, as I would say, code it up so that you can test it. Unfortunately, most people think that this area is the heart of software development. Importantly, you would have learned, or you will learn in future, that this might be the area that is least important in the grand scheme of things, because if your requirements are not done properly and then you don't have a proper design, then your implementation won't be as good as you would want it to be. And so it therefore means that you need to pay a lot of attention to your requirements and your design, because all you're doing after you have done your requirements and your design is doing what you said you were going to do. Yes? As you will realize, I usually use the building example. The customer will desire to have a particular type of house, and they might provide a description to the architect. The architect does the design. Yes? And then once that design is approved, you get some workmen and they implement what is there. Now, recognize that the greatest value really is in doing the design properly, in the building process. And maybe if you ask me, you know, there might be a significant lesson to learn as to who has to do more of the intellectual or even the, other types of work, right? Because a properly architectured building requires all kinds of drafting and how electrical is going to run, or plumbing, all that kind of stuff, the kind of structure, the type of material, and so on. You have to detail how these things are going to come together. And then thereafter, what you do, you just get somebody to do it how it is specified. So that's just, you know, an example from outside of this domain. So, as the note said here, almost all important decisions are made during the requirements and the design phases. And so implementation just does what is to be done as specified in the requirements and design. And so what implementation focuses on is really how to code, the coding details, and your style and your documentation, right? And as you will see from today, when we are finished with a class diagram per se, you will recognize that we would have determined how things are going to be done already, how they're going to relate to each other, what classes are going to be required, and so on. So you can just give that to somebody and say, implement this. All right? Now, testing is always important, because if it's not tested, you can't tell whether or not it works. And so obviously, once you implement, the next thing you do is test. With me, Barbados? Yes. Any questions? Good. All right. So then, we can start talking about how do we actually go about identifying classes and objects. As you would have seen from my previous slide, right? When I talked about design here, we talked about functional design and we talked about object-oriented design. Our focus is going to be on object-oriented design, but I wanted you to realize that object-oriented design is not the only option. There are other options, okay? All right, but of course the course is called Object-Oriented Programming, so that's easy. Now, the core activity of OOP or OOD is determining the classes and objects that will make up your solution, because in this type of design, everything has to relate to a class, which eventually become objects. Okay? So whatever you're doing must be assigned to some class, right, that is going to perform that activity. Anything you're going to do. Okay? Just like how if you were doing functional design, one of the units that you determine, for whatever reason, must be carrying out the functions that will eventually give you the overall solution. Otherwise, there's nowhere, it's not going to occur in a solution. Right? So one way of identifying potential classes is to look at the requirements, yes? And start to do some, you know, extraction based on nouns and verbs, and then you go through a process thereafter to, you know, refine that list, and then come to some consensus as to, okay, what is going to be my final list, right? And once you have dealt with that, then you start dealing with how they interact and so on, okay? Now, if we have a statement, for example, that says the software to be designed is a program that can use and maintain an address book. Notice software and address book and program are nouns. An address book holds a collection of entries, each recording a person's first and last names, address, city, state, zip, and phone number. It must be possible to add a new person and to address book edit and to an address book and to edit existing information about a person, except the person's name, and to delete a person. Okay? Now, there are different ways of writing requirements, right? But generally, a requirement must be descriptive. Okay? Yes? Okay, so here we have some details that kind of give us a set of things that our final program is supposed to be able to do, right? And so from that, as you note, we underline the nouns, right? Everybody find with that? Didn't miss any, even when they didn't seem sensible, because we want to get an exhaustive list first, right? And then we can move to refining that list, all right? Now, the important thing to note here also is that there may be some things that implicitly make that list, even though they're not explicitly stated. Okay? It might be as a result of just brainstorming, right? And recognizing that there may be some detail that are hidden in the description or the requirements that you have, right? Now, here's our list though, or our candidates based on the description that was previously read. Okay? Hope I didn't miss any. Good. Now, from there, we can rationalize the list and determine which things don't really make any sense. So from that, first thing we do, remove synonyms and duplicates. Software, program, collection, information, you know, then we find that name is a synonym for first and last name together, right? First and last name is a little bit more detailed, so we keep that and we cross out name, okay? And so we have a rationalized list. Now, remember that a class represents a group or a classification of objects with the same behaviors. So generally, classes that represent objects should be given names that are singular nouns, and we talked about that, you know, in the past weeks. So a class represents the concept of the object, remember that, and then from that concept you can instantiate one or many of objects of that type. So one person class is defined. A program can create as many person objects as needed. Each person object will have the characteristics that are defined by the person class, and so on and so on. Okay? Now, sometimes it's challenging to decide whether or not something should be represented as a class, right? So that's where you realize there may be some differences, right? From one person who's designing an application to the other, okay? So for example, should a person's address be represented as a set of instance variable or as an address object? That's a decision you have to take. Should we represent street, zip code, apartment number as 3 different things, or should we create another class called address which has those things as attributes, and therefore we would have an address object, right? That is a part of that. Now, as you move forward in the process of identifying objects and actually applying some more review to it, you will actually clarify some of these things and look at the pros and cons of doing them one way or the other. Now, so from a little bit more work, we rationalized our list further, and we decided on how we're going to be representing. And this doesn't mean that this is the only way of doing it. This is one way of doing it, right? Now, in this rationalization, we would have removed, well, we would have classified the different nouns as to whether or not they are more like objects, or sorry, they are more like classes or attributes. So we notice that first name, last name, we have a discussion to have about whether or not to represent address a particular way. But in any case, city, state, zip, and phone number are all attributes, whether they be attributes of another class or of a particular class that we would have decided on already. Let's say person is not a decision that we take as yet. Okay? We just want to say, okay, which of these are going to be attributes and which are going to be classes. Right? Now, further from there, we have the list of those things that we say we finalize that are going to be actual classes. All right? And we came up with 2, and it's noteworthy here that your object-oriented design actually starts the process. Well, the object-oriented design is started when you start identifying candidate classes. All right? Now, once you have identified the classes that you're going to be using, then the next thing you have to do now is to work out how you're going to structure those classes and how you're going to map the relationship between all the classes so that it comes together to produce the things that are set out in the requirements. All right? Now, we're going to introduce you to one particular method called class responsibility collaboration method that helps you to come to, to develop these relationships, right? In a kind of practical way, right? Rather than the specification. The specification of it will come a little bit later. But CRC is a way of working in teams, right? To come up with the classes, their responsibility, and the collaboration that they will do in your application. So let's look at the CRC method. Now, it's really a brainstorming tool that is used for object-oriented design. It usually is best applied in teams where each team member creates a CRC card and the team engage in playing cards to define the structure of the program by interacting structure of the program by identifying interactions among the classes, because everything is going to be done by a class, which means that you have to identify which class is going to be doing what, right? At this stage also, you might discover classes that may have been overlooked from the preliminary work that we did with the requirements, okay? So here's where we start. We start with a card, an index card, right, or a piece of paper, and you write down the class name, then you create 2 columns below that, one with responsibilities and one with collaborators, right? Now, the class name, we found that already. The responsibilities, right, these are the tasks that the objects are required to do. and the collaborators are any other classes that are needed to do any task associated with this class. Okay? So, part of identifying the classes we need is the process of assigning responsibilities to each class. We generally use verbs in order to identify the responsibility of a class. We did nouns to identify attributes and classes already, so we're now using verbs. All right? All right, so identifying responsibilities, let's think about the person class, which we already decided on earlier. Some of the responsibilities the person class will have, it should know its last name, know its first name, know its address, city, and basically know what is in each of the attributes, yes? Now, notice we left out one. Did you realize that one? What did we leave out? Barbados? Well, I'm not hearing it, but I think you might be getting it right. We left out the ability to create an object, right? So if the person class don't know how to create an instance of itself, right, then that's a problem. Because that's the primary thing, right? That it needs to at least be able to do first before it can know all the other things. So see, I put it in now, right? So should be able to create a person object, given last name, first name, address, city, state, and zip. Yes? And so far we have identified no collaborators because there is no external class that will be required in order for the person class to carry out any of the responsibilities. Yes? So if in order to know last name, the person class needed to use another class that would write it in there. Inside collaborators. Yes? Alright, now, so the person class can carry out all of its responsibilities without using any other class, and so there are no collaborators. Some classes will need to collaborate, however, with one or more other classes. Alright? And so in the CRC method, collaborators are identified by playing cards. So each team member is responsible for a set of cards. All cards are placed on the table, and then you use scenarios to play out. Okay? So something like, say, you pick a card, so a random card is picked, the team member calls out a responsibility, right? Then you ask other team members for help with responsibility if needed. The team member that responds holds the class that has the responsibility. And you just insert that in the collaborators, yes, section. Yes? So, here's an example. Suppose we were team members, Barbados and WJC, and I just said, I want to add an entry to an address book, right? Now, team member holding up address book card might say, I need to create a person. Team member with person cards hold up, I can do that. Or I should be responsible for that. Team member holding address book card adds person as collaborator. Yes? Because in order to add an entry to the address book, right, I need to be able to create a person, right? And then that person can be inserted in the address book. Okay? Any questions? No. Okay, so that game continues to play out until all of the responsibilities are identified, right? And each time we play out a scenario, the collaborators are updated, right, until we're done. Okay? Now, generally, the scenarios are going to be directly related to the requirements that are set out, right? So for example, in the requirements, it might say we should be able to add a person to the address book. So you play out that scenario, yes? So it's not something you pull out of mid-year, okay? Now, playing the cards also can result in the discovery of other classes that were previously overlooked. So let's say a user might need to be able to put in the details that are required to create a new entry. We didn't create a class for that, right? So there might be some other responsibilities. Now, sometimes we overlook that, but generally, those kinds of interactions are usually done by the user interface. And so, just like how when you're writing your program so far, you create what are called driver classes that you use to pull everything together to allow the program to work, right? In our case here, we're going to suggest having a class called address book GUI, where it is going to now have the different functionalities presented to the user so that they can actually do the things that the other classes provide. And so let's look at the responsibilities. So the address book GUI should allow the user to enter details for an entry, allow the user to save details of an entry, allow the user to delete an entry, allow the user to search, display, and so on. Okay? Now, which class is going to allow that to happen? As you would see in the collaborator section, right? In order to save the details of an entry, you need to collaborate with the address book, right? In order to allow a user to delete an entry, you have to collaborate with the address book, and so on and so forth. Yes? Now, putting it all together, we realize that we have 3 classes with their responsibilities and their collaborators. Okay? We looked at all of these one by one already, but now we're getting closer to the full picture of which class, what each class is going to do, and who will be working together in order to get it done. Right? Now, there are a few points to note. The CRC model can be continuously refined to detail all classes, and you can do it over and over and over again. It can also be used as a tool to explore, to see if you're missing anything, or to see what else needs to be included in your overall class identification and design. Now, there's some more additional reading that you can do, and there's a link that is in the slide which you can pay attention to. All right. Now, once you've identified your classes, right, their responsibilities and their collaborators, then generally the next stage is to move on to construction of what we call a class diagram, which is going to take you closer to some other things that we cannot model in CRC, closer to what is going to be required for implementation. All right. Now, we're going to look at that in the next part of today's lecture. All right. All right. So we're going to look now at using UML to create class diagram, and UML stands for Unified Modeling Language, and it's just a method for doing object-oriented design, and a class diagram is just one of the models that you can create in the UML. All right, I'm sure you will get much more experience creating models or different type of models in UML as you do more courses in computing. All right, so remember, object-oriented design is concerned with identifying classes that are required to write an object-oriented program. identify their relationships, describing the methods that each must provide, and describing the attributes of each class. Now, it's good to describe the attributes, but that's something that evolves and is not strictly a part of the core activities. Because attributes can be derived, they can change, they're not as important as making sure that a class has certain responsibilities. As a matter of fact, you have a class and responsibilities. In some cases, there are classes that don't have attributes, right? Now, once the design is completed, the classes can be implemented using some language such as C++ or Java. Java is our preferred language for this time around. Of course, I mentioned that you have to test, right? And the first part of testing is testing each actual class, right? And then you can put them all together and test them and to see if they work, right? When you integrate them. So we're going to focus on UML as a language for writing your design. So let's look at a little bit of syntax. When you're specifying a class in UML, you use a rectangle which has 3 segments, right? The first segment, you write the class name. The second, you write the attributes. And then the third, you write the methods. Simple, yes? And we know our classes already. We always write them starting with a capital letter, right? And we keep that going. So, an example here, let us identify what each is actually saying. Okay? Now, if you notice there, you see a minus sign, and then you see name. Then you see a colon, and then you see string. So there are really 3 things that we need to be concerned about here. The minus sign is used to determine or to specify the visibility modifier. In this case, minus means private. Okay? You started to write some classes already, so you would have seen private, and we told you what that meant already. The plus sign means public. And then the third visibility modifier, which is protected, you use a number sign, or what we call the hash. Okay? Now, so in this case, we have a name which is private, and then we have the type, which is string. So what comes after the colon is the type. So name is of type string. Yes? Of course, page name suffix. What is that really? What is that really? Anybody want to guess? Barbados?
A constant or something?
Very good. Because we already said that as a convention, we use uppercase letters for constant. Now, notice it is also public, all right? And that might be because, yes, it is something that is going to be visible outside of the class, yes? Then, in the third segment, we write the methods or the operations. Notice all of our methods in this case has the plus, and that therefore means that they are public. Then we also have the semicolon and the type. Now in this case, the type that comes after the semicolon is talking about what is returned by the method. Yes? What is returned by the method? Now you will notice that we have round brackets after the method name, and in the case where the method takes something in, we put those parameters inside those round brackets, just as with the case with set name here, where we put new name as the variable that it takes in, and we separate that and note that new name is of type string. So for every parameter, you give it a name and you say what the type is supposed to be. And then of course we continue by putting void, which means that this method set name does not return anything. Now, if you think about it, just for a moment, if I, for example, give you this diagram, right, and say go and implement this, I can almost build another part of the application that uses things from article without seeing the details of how you implement this. Do you agree, Barbados? So if I wanted to, for example, create another class called book that is going to collaborate with article, because I know all of the methods that are in article, right, and all of the attributes and their types, I should be able to use article. Yes? Everybody with so far? Stay focused. All right. Now, it is uncommon to have just one class on a diagram, right? Because your program is going to be made up of a group of classes that are interactive. Yes? And you have seen with the small application we were talking about earlier, right? We identified at least 2 classes and eventually we moved on to 3 classes. Yes? Now, this class diagram is an example of what maybe an order processing system might be composed of. Now, you will realize that we are using the same rectangle with the 3 segments, but there are some things that look a little different, not true? Yes? Now, you notice, you see certain types of lines, you see some numbers, yes? Yes, Barbados? You see a star, you see some dots, and you see this little special sign here, right? And we wonder, what are those things? All right, so let's talk about them. Now, classes can have different types of relationships. So, remember earlier, we identified responsibility and collaborators. Okay? Now, that collaboration basically can mean different things. In some cases, right, a class can use another class. A class can have another class within it, yes? Or a class can be a version of another class. So it is a, okay? Now, we are going to look at dependency and aggregation. The is a relationship we're going to do in a completely different lecture because it's a fairly extensive topic. And we're going to do that under inheritance. So let's focus on A uses B or A has a copy of B. Yes? Now, the uses relationship, right, we're going to focus on. So a dependency exists when one class relies on another. We've seen dependencies in many previous examples. We don't want numerous or complex dependencies among classes. It's not such a nice design if you have that. Okay? And we're going to talk about some things called solid principles. We're going to start talking about it today. We're going to look at one aspect of solid, which is the S. And then we're going to look at the rest of letters as we go through the course. So eventually, as you design, you keep these in mind. All right? Now, the first dependency is shown with a dashed line here. And it is a case where one class uses the other. So remember, in your programs, all of your programs so far, where you wrote a driver class to test if things are working or to provide the options to use the application, and that class probably as your main method, right? That class uses some other class. So for example, when we were doing the account example, you know, we created a class, account tester, I don't know what it's called, account driver, and inside of that, you instantiated the account, several copies of the account class, for example. So that is a uses relationship. Okay? And that is depicted by a dashed line and the arrow. Now notice the arrow is going to the class that is being used. Yes? Now, the other type of dependency is aggregation, and it's really about a hazard, right? Kind of relationship. So let's say, for example, if we had chosen the particular design that we were talking about earlier with the address, a person that has an address, we could have created another class called address, and inside of the instance variables, we created an instance variable which is of type address. So basically, the person class would have an address as one of its instance variables. Yes? Now, this is a special kind of dependency, right? Because the aggregate relies on the objects to compose it. Now, we're going to look at two types of aggregation, right? But let's look at this example first. Consider a student object is composed in part of address. Oh yeah, I just talked about this a while ago. All right. This is what it would look like. So remember, we had the uses first, where the student test, which is our driver class, uses the student class, but the student class is made up or is composed of, right, the address. Okay? Now, notice something also. Notice we have two on the line. Like I showed you in the earlier picture, where you could have one or any number, and you could have a star and a dot, and so on. In this case, what we're essentially saying in this diagram is that a student has two addresses. Yes? So the two address is a part of the student. And of course, we still write them, the attributes in here, and put the type. Everybody happy? Good. Now, just to give you an idea of what these actually mean, when we have one, it means one instance of the class. N can be any number. It could be 3, it could be 5. So in this case, our 2 would represent N. Yes? And then star means many or any number. Now, if you have 1 dot dot star, it means 1 or any amount. If you have 0 dot dot star, it means 0 or any amount. Yes? Now, the lines, I told you what the lines mean, but all of a sudden now I have two different symbols for aggregation. One that is black and one that is clear. Yes? So one with a fill and one without. Now, what does this really mean? Now, we can break up our aggregation into two categories. Either it's weak or it's strong. Now, strong aggregation is called composition, and weak aggregation is just weak. Sorry. Now, for weak aggregation, it means that although another class is using the other class to make up a part of it, it doesn't mean that if that class doesn't create an instance of it or use it, it ceases to exist. So I thought of an example that would be useful, and I like this one. So in this case, I have any amount of players to any amount of teams. Notice the star? Yes? Good. But then I have a clear symbol. Yes? So that means weak aggregation. Now, this is saying that players may participate in many teams at the same time. For example, they can play a city, league, or a company team. When a team is disbanded, the players still exist and can be reassigned to other teams. So the player can exist on its own without being in a team. But team, right, is using up players to make it up. So inside a team, you would have players. So team depends on players. The other option is strong aggregation, where now our symbol is filled, right? And in this case, a chapter cannot exist unless there's a book. And many chapters are in one book. But if there's no book, there can be no chapter. And it's not true, right? A chapter don't exist unless it's assigned to a book in real life, right? It might be a document, but if there's no book, it's not a chapter, right? So that is the idea here. Now, in general, if you're unsure, usually you use weak aggregation, right? If you're unsure as to whether or not the relationship is strong or weak, start with weak, because strong is saying really that one cannot exist without the other, right? And that really means that there's no use for one if the other that uses it is not existed. Now, strong aggregation is called composition, all right? And then, of course, the other, as I said before, is just weak. Any questions?
No.
Okay, good. Everybody is happy. All right, so we call the CRC model for address book, right? Yes? You've seen it before. Great. Now, which you prefer, CRC or UML? Or which is better, CRC or UML? Well, the thing to note is, remember I started out by telling that CRC is kind of an approach where you play cards, right? And you brainstorm, right? And it allows you now to kind of ferret out things, okay? It is not a formal notation. It's not something that you can take and now translate, really. It's a starting point, right? Now, you will however see that CRC card name becomes a UML class, for example. Responsibilities tend to become methods, right? And there's a relationship between a class and each of its collaborators. So the class holds an instance of a variable of the collaborator class type, right? Or the class uses an instance of the collaborator class. So there are some things that benefit significantly from doing CRC. And by the way, when you reach UML, you must know what classes you have already. You must know, and you need to now be starting to specify details like type, right, of variables, right, and the type of relationship. Not just that there's a collaboration, but you have to specify the type of relationship, because that now is going to be useful for you to know where to go in the next step where you do the implementation. All right. So as I said, at the UML stage, types become important, okay? There are some differences though. Some concepts that are modeled by the CRC method are not representable in a UML class diagram. A UML class diagram only shows the structure of program, right? Not the interactions that occur when the system runs. Of course, interactions are modeled using a separate UML diagram called a sequence diagram, right? Some decisions have to be made at this stage that are not important in the CRC model. So things like, now that we're going to implement a person, what tells one person object different from another person object, right? So maybe name is not enough. So maybe you have to add an attribute that is going to be the unique identifier, such as an ID, right? Last name and first name may not be enough, right? Now, will we use index to carry out operations? Oh, sorry. Let us design our classes so that each entry has a unique index in the address book, for example. So for the address book class, we can say each entry is going to be implemented a particular way, right? Let's say we use an array or an array list, which means that each entry now is going to be stored, right? And then we now have to carry out operations on the person based on the index of the particular entry. So now we can look at specifying the address book class. Notice here, we didn't do it before, the address book is going to be composed of people, a people array, which is going to hold a list of what? Person objects, right? And then if we use an array, then we might want to maintain a count of how many persons are in that array. Yes? And then we can write the other classes that are going to allow us to perform the operations as we previously determined, like add entry, delete entry, and so on and so forth. Okay? Now, some classes that are identified in the CRC exercise are classes at the boundary of the system, and that includes, for example, the address book GUI class, which is going to be used to allow the user to interact with the system. All right. The responsibilities of this class do not need to be methods. This class needs to use the address book class. That is, the address book is not part of the address book GUI class. So what ends up happening in the address book GUI is that it invokes the methods that are associated with the address book. So it uses the address book class. All right. So you don't need to actually implement the things that it's going to be doing, but rather make sure they are accessible or can be invoked. Yes. So address book GUI basically just does one thing: create a new address book GUI with an instance of the address book. That's what is passed into, and therefore, once a user is using the address book GUI, then they will have access to an address book that is passed into the GUI. And then from there, they can do everything that they want to do. Yes? So notice the address book GUI here doesn't have the operations of add an entry, delete an entry, and so on. Those are implemented in the address book. Yes? All this is doing is providing an interface for the user. Another note on class relationship. The address book GUI class uses the instance of the address book. I just told you that. This can be seen from attributes that. Now, the structure of the program is depicted by one diagram with all the classes, and this is what our structure now looks like, where address book GUI uses address book, and there's a weak relationship, weak aggregation between person and address book. Okay? So address book uses person, just like we did a while ago. All right, so that's putting it together. All right, so that was just a simple example of how to use UML to create class diagrams and how to show the relationship between classes. There are some broader principles that I want you to pay attention to. The first thing to note, though, is that not everyone is going to come up with the same design, right? I always use the building example again, that if the customer comes to an architect and say, I want a 5-bedroom house with 3 bathrooms, and he might have a constraint to say that all of it must be on one level, no upstairs. I don't want any slab roof, and I want to make sure that I have adequate cooling so I don't have to use AC. Those are my requirements and some constraints. Every architect that gets that description is going to possibly come up with a different layout of how to get those bedrooms together and how to make sure the structure of the house is such that it meets the constraints of my requirements. And it's the same thing with designing a program. Everyone who gets a description can come up with their own design. Now, it therefore means that everybody could do the same thing differently. How do we then assess whether or not a design is good, bad, or indifferent? Of course, there's a lot more to the assessment of design, but there are some general guidelines which have become what we consider best practices for object-oriented design. And they are called solid principles, and you can also read these up further. Now, each of the letters in the word solid represents a particular principle. We're going to look at OLID as we go along. So as we do more, we're going to bring you back to the solid principles and indicate examples or how this principle could be applied. So moving forward in our subsequent lectures, we're going to be looking at the rest of them. But for today, the one that I want to leave with you is single responsibility, S, which says that each class should have a limited set of responsibilities. And you can identify with that because today we identified class and responsibilities, right? And collaborators, which is now which class is doing what and who else is required to help it do what it's doing. So we're saying that each class should have single responsibility, which means that limited, a class should not have more than a few. These should be logically related. So you don't want a responsibility in a class that don't really relate to that class. Put it somewhere else. Right? Now, you don't want to have an account class, and inside the account class you have weather, as in the weather outside. Yes? And then you probably have inside the account class, you know, yes, things that don't relate. That's just simplifying. That's a forward one, but yeah. A large class should be probably split into several smaller classes. You don't want too many responsibilities and or attributes, right? Because as you will realize, that makes things a little bit difficult to maintain and to manage as you get further into your design. If one class is doing too many things, right, then what you're going to find is that some of the things that may be reusable automatically cannot be reused. And we're going to talk about that a little bit more as we move forward. And that is the end of our lecture. I will now take any questions that you might have for today.